Hello, everybody. I'm going to grab some water. While I grab my water, if you go to that QR code, you will see this slide with stuff that you can download and install. You can also just type that, but because I'm not going to do any coding, I'm just going to show slides and talk about stuff. So it's up to you to do the coding. We have an hour and a half, and I did this presentation a few weeks back. It almost fit in an hour and a half, so we have to go fast. If I'm going too fast, let me know. Wave at me if you have any trouble understanding what I'm saying or what's on the screen. Let me know, slow me down, wave at me, yell at me if I don't respond. If you have any broader questions about what's going on, please approach me afterwards. We can talk about it. After this, I'm running to a developer meeting though, so I stick around for a little bit for some questions, but when you see me walking around at the conference, just come up to me, I don't bite. So this is about add-on development, and we're going to look at the very, very basics and then gradually move on. Things you need is a computer that runs Blender. I have a zip file of like the final form of the add-on that we're going to make. So you can just download it, unzip it somewhere, use it as reference. You need Blender, obviously, and if you actually want to do the coding right here on your laptop, you need Visual Studio Code with two extensions, the Python one and the Blender development add-on, well, extension thing for VS Code. Once you have that installed, press Ctrl comma or Command comma, search for reload on save and turn it on. By default that's off, but for us it's kind of nice when you save, you go to Blender, you see your changes immediately. Okay, so this is the first thing you'll see when you go to that QR code, so I'm going to move on. What we're going to do after the introduction, just go over some Blender and Python basics. We're going to make an add-on, we're going to put operators in there, talk about custom properties, user interfaces, and then we're going to strip out a little bit about what that very useful add-on added for us with the auto reloading and stuff and auto discovery, and we're going to take that out and write our own. And then it's pretty much like the conclusion of the thing. That's what we're going to make, something with monkeys. So follow along. The slides are on there, so it's not just the first slide, but you can just use the arrows. As you can see, there at the bottom it's boinking down. That means that we can also go downwards. If you press escape, you don't see that. Anyway. So Blender and Python, I'm going to talk a little bit while people are setting up their laptops. The QR code stays on screen for a little bit. When you're in Blender, go to the preferences, and in the interface preferences, there is checkboxes for developer extras and Python tooltips, and you want to turn those on. Because that's going to show us some useful stuff that we're going to use later. Because once you do that, you can just hover over any property, and it will give you the regular tooltip, but it also gives you this Python bit there, object.location, and that's the property that you're looking at. It's owned by the object, property is called location. Underneath that, you see the path of how you could get there. If you go to the interactive Python console and type bpy.data.objects cube.location1, you get the Y location of the thing. Don't type it. We're going to cover that later. It's also, Python is used as the glue code in Blender to glue hotkeys and user interface elements and glue that to actual implementations of functionality. Blender comes with the built-in text editor. I think you guys know that. And usually what you have is operators that are either made in Python or in C++, and that's then linked to menu items and buttons and that kind of thing. Also, Python is used for a lot more. So importers, exporters, automated tests, extensions, command line tweaks for background rendering stuff if you happen to work on a render farm. So I have some questions for you guys. Who has never used Blender? One. Amazing. Welcome. Who has worked with Python? Oh, that's great. That's great. Who has used Python in Blender? Oh, you're going to know all of this stuff. Who has used compiled languages? Yeah, okay, good. Who has compiled Blender for themselves? All right, all right, all right. That is very good. So the people who want to do like the following along, is everything okay? Is Visual Studio Code running? Good. First thing we're going to do is just turn off our brain and just copy paste. That's how all developers start, right? And so first we want to paste into something. So let's find the Python console. If you have a user interface that you blew up bigger so that you could take screenshots for your presentation, you have to scroll that top tab bar and then you click on scripting and there you find the Python console. It's the thing here with the green text. Now if you go to the properties panel and you hover over the location X, you can see the Python path. And then you right click, copy full data path, and then paste that into the console. And that will just give you the location of the cube. Super simple, copy paste, there you are. Oh, by the way, if you want to follow along with the slides, you can click on the orangey button. That copies that text to your clipboard and you can just paste it. There's no need to type everything yourself, that way we can move faster. So the top one is the one that Blender gives you, because location is like a three-dimensional array of multiple things. You can also use .x, .y, .z. Personally, I like that more. It's exactly the same thing for Blender. And you can assign things to it. You can say this is equal to 1, and then all of a sudden you see the cube move in the 3D viewport to the new position. You can add things to it or subtract, like minus equals says subtract, plus equals said add this to the thing. You can also remove the .x and assign all 3 coordinates in one go. So between the parentheses, you have a tuple of 3 things, just assign it. And that's how you can move cubes around the screen. I think we're all on board so far, right? Excellent. Now, operators, you can also copy-paste them. And I think this was, whoever thought it up, I don't know, is brilliant. But you can, like everybody knows, like Shift-A or add and then go to like the icosphere. You click on it, you get an icosphere. But if you don't click on it, but you just hover your mouse, you press Ctrl-C, you actually copied the Python code to run that operator. And if that menu item also had like extra settings for that operator included in there, that gets copied along with it. So you press Ctrl-C, you go to your Python console, you hover your mouse over there, you press Ctrl-V, and all of a sudden you have that line over there. You press Enter, you get your icosphere at the 3D cursor where you would expect it. But also you can remove that last parenthesis, so arrow up to get the previous command, and then remove the parenthesis, press Tab, and Blender will spit out the rest. And then you can see you have a subdivision option, you have the radius, the calculating UVs. There's a bit of a weird thing here where Blender claims the scale is defaulting to 0. It doesn't, but still think so. You might recognize these options from the redo panel because they're exactly the same thing. So that way, like Blender can tell you what the options are and how to use them from Python, what they're called, etc. Then I've heard many people talk about the info window. That's the thing that you see underneath the Python console, and it's super handy to see what's going on and which operators are running when you do stuff in the 3D viewport. But I just want to mention that it's like, don't put too much faith into what that thing is showing you. This was me moving the cube. We were just doing like the blah.x equals 1, that moved the cube. If we want to do all 3 coordinates at the same time, you just, same one-liner, you just remove the x and give it more stuff. This is so much harder. Like, it shows all the options, including the default ones that nobody ever set, but Blender still uses. You can see it does a translation of a certain value. So yeah, you can move it by 1, but if you want to set it to 1, you first have to know what it is now, subtract the thing, then you know by how much you want to move it by. Like, so that's the last thing I'm going to say about the info window. Where to find more information? Well, Blender's user interface. Like, the Python tooltips are wonderful. I use them all the time. I don't remember most of that stuff because it's so easy to find. Also, there's the Python API reference for Blender. You could just go to Blender, help, Python API reference, opens a browser for that version of Blender that you're using. There's the documentation. Also, the Python standard library docs are pretty good. The Blender's Python is as close to standard as we can, so that all kinds of general Python tutorials that you can find actually also apply to Blender. So let's keep going, because we copy-pasted that long thing for the cube, and that's great if you only want to move the cube. These are the kind of data paths that you get from Blender. So it's the monkey, or it's the material with a specific node tree and then a specific node, and it's really that thing that you hovered over and right-clicked on. But often this is not what you want. You want something like, give me the currently active object, give me the current selection or the current scene, all that kind of stuff. And that is what is accessible through the context. So there's bpy.context.something. Often you will get a context parameter. For functions, you'll see a few of those. If you get a parameter, use that one. And so that's it. That's how you get to selected objects and stuff. Now, I want to briefly move away from Blender a little bit to talk about like a really Python basic thing, but I think it's good to know. And that is, names refer to objects, and that is how Python works. So there's not a variable in memory that is of a type int, and so that has 32 bits, and that is the name of the thing, is that piece of memory in... No, it's just, you have a number in memory that is the object, and you give it a name. You can give it 5 names if you want. It's still all naming the same thing. So a bit more concrete example. We have a stack of monkeys. There was a photo of mine back in Bali. I thought they were really cute. So you can always say, like, see that ledge over there with the 3 monkeys on top? I want to have the third one from the top. And that is sort of the path that Blender gives you. I just name him Steve, and I think that's a lot easier. And Python works that way as well. So you can, this is what you get from Blender, and then you can just say, well, that is, I want to call that Steve. Steve doesn't know he's called Steve. That's just between me and my code. Steve knows nothing about this. This also does not change the name of the object. This is just another name that I give to it in my Python code. So instead of saying bpy-data changed by a half, I can just say steve.location.x changed by a half. Makes my code a lot easier to write, easier to understand. Also, this is faster for Blender, because if I were to do like 10 different things on Steve, it already knows what Steve means, and so it can do the 10 things on there. If I copy-paste that line 10 different times, then 10 different times Python will look up bpy, the name. Then on bpy, we'll start looking up the data. On data, we'll look up the objects. In that whole list of objects, we'll start looking for the object called monkey. And that for every single line of code where you copy-pasted it. So just call him Steve, or whatever makes sense. Python is Python, and so those names are not linked to any specific type. So if I say Steve is 3, yeah, fine. Then Python, whenever I say Steve, it refers to that 3 in, and so that no longer has a location and will give you errors. That's how it works. So let's start doing things, because this is all introduction. You know how to move a cube. But when you want to do things on like 1,000 objects, then coding becomes a bit more interesting. So if you copy paste this into the Python console, then it will print all the names of all the selected objects. In the Python console, when you look at that little header of info that you always ignore because it looks like a banner, you will see that it has some convenience imports. And capital C is a shortcut for bpy.context, and capital D is a shortcut for bpy.data. So basically that's like 2 more Steves. That's just easier to type. In your own script, when we later look at like writing your own script in your own file, these shortcuts are not there unless you put them there. So we can also change the objects. We can loop over all selected objects and say op.name equals op.name.upper. Turns the name into uppercase, assigns it again to the name property, and this renames all your objects. This can already be quite useful if you don't take that uppercase name, but maybe you look at, I don't know what kind of thing in your scene that you want to put into that name and make sure that everything is named correctly for export later on into a game engine or whatnot, then this becomes useful. Let's take it one step further. Let's say we want to select all hidden objects that have .00 in their name. Random thing, but it's starting to become a little bit tricky to do this on the Python console. So we're going to move to the built-in text editor. You click on New. You copy-paste the code from the next slide into the text editor. Click Play. That runs the script. This is the code. So again, we're going to loop over all the objects in this case, all the objects in the scene. First we're going to deselect everything. Again, I did not write this code. I went to select, none, hover, copy, text editor, paste. Then for op-in context scene objects. If they're hidden, if op.hideGet, they can be hidden on different view layers, so that's why it's no longer a simple property but a function that does some smart things. If op.hideGet, so if it's hidden and .00 in the object name, we're going to do stuff. We want to select it. Selecting a hidden object is impossible, so first you have to unhide it, and then you can select it. So this works, but I'm using this as an example of code I don't really like, and that is because it's in the shape, if it's okay, do the thing. And if you keep that as a way you always write your code, for short snippets like this, it really doesn't matter. But when things get a bit more complex, if it's okay, then we start looping over something else, and if it's okay with that something else, then we do the thing, and everything gets pushed away from the left margin. And it becomes really hard to visualize what is the core component of this code, what is the main functionality that it's doing, because it's pushed away into clunks of conditions. So to keep this a simple example, what I would do is flip the conditions and do early continue. So if it's visible, continue. And continue means ignore the rest of this loop and just go to the next object. So if it's visible, it's not interesting. If .00 not in name, it's not interesting. So also I continue. And then I do the thing. Oh, I realized I didn't fix the bug in here. This is selecting first and then unhiding, and that's not going to work. In any case, this has helped me a lot in just a tool in my mental tool set that if it's uninteresting, skip it, generally gives you better code than if it's interesting, do it. Because if this gets more complex and there's more conditions, this block will just move down. And you can still see that, oh, for all the objects, after the checks, this is the thing that we're doing with it. So that's something I just wanted to show. We've done our printing of the names earlier of all selected objects. If you do this now in this code in the text editor of Blender and press play, you won't see it. And that is because it's no longer associated with that particular Python console, and it will appear on the standard output of Blender, which only on Windows you can easily get by going to like Window Toggle System Console. On Mac, on Linux, other systems, you have to start it from a terminal in order to see the standard output of Blender, and there you will find your print statements. It is what it is. So let's do more monkey work. Something like this, nowadays you would grab GeoNodes, but we're going to script it. So we're going to create 600 tiny monkeys. So I loop over a range. This is how you would write a for loop that goes from 0 to 599. So this visits 600 things. I get my index, that's the number. I take modulo 25, that's the remainder after dividing by 25. That gives me the x coordinate. Y coordinate is // so that's integer division. If you were to use a single slash, that would give you a floating point number. So then it would just gradually move down. I wanted to have 1 row, 2 row, 3 row. Python used to do int divided by int, always produces an int, so 1 divided by 3 is 0. Nowadays you get a third, because that's more, feels more natural, but if you still want to keep that integer result, you use the double slash. And then we can pass that to the location tuple. The z coordinate, I don't care for my grid, I put it at 1. You can pass a size, and that will give you the 600 tiny monkeys in a grid. The nice thing about Blender is that when it adds something new, it will deselect everything else. And that means that we can add more operators here. So if you want to have 600 tiny subdivided and smooth monkeys, you can just add that smooth subsurf modifier. You can call the smooth operator, and it will apply to each monkey one by one as you add it. Okay, let's look a little bit at editing code, because we've already seen the built-in text editor, and it has a bunch of big advantages. It's built-in. That's nice. It has syntax highlighting. So if you name the text block without an extension, it will assume you're writing Python code. If you name it .py, it will do Python syntax highlighting, but I think there's also some other languages like GLSL shading and that kind of stuff. Syntax highlighting for, you just have to type the extension. The text data block is saved to a blend file, so it's not necessarily a file on disk, it's just code that sits in that blend file. And it also comes with a whole bunch of examples. So you go to, I think it's template and then Python, and then you have a whole list of example codes that you can learn from. Also, there's this register option. If you go to text and then there's register, and that means that it will automatically run when that blend file opens. And pretty much at the end of this class, when we go to the ripping out what the Visual Studio Code add-on gave us and writing things ourselves, we'll go to the registration stuff. But the cool thing is that you can then have some code that runs in that blend file. You don't need an add-on for it. So for generated code, like the rig UI of Rigify, that is put into the blend file with the rig. And that means that you can use an add-on to generate that rig, but to use it, you don't need the add-on anymore, because that rig file is now self-contained. And that is super powerful. There are cons, though. I find it really confusing to work with files on disk. Because if you go file open and then open a Python file from disk, it... No? No? What?
We went to slide 13.
What happened? More?
Your slide's on 13.5.
That is weird. I was there. with a register. Let me see. I'm just going to reopen my... Wow, this is wildly going weird. You know what? I am going to mirror my screen so that I see what you see. I think that's better. No. Now you see what I see what you see, but no. Yes, there. Yeah, you can read my emails. Well, it's Blender, it's public. Yes. Yes, the common pitfalls, of course. We were at looping over stuff and creating stuff. Before we go to the next thing, I just want to talk about the pitfalls. And something that's quite common is you loop over something. While you're looping over something, you're manipulating that something. So to give an example, I've made the mistake all the time. So this deselects all selected objects that have .00 in the name. Very close to the code that we were writing before. Same approach as what we were doing before, with just deselecting instead of unhiding and selecting. So what's wrong? Can anybody tell me why this will misbehave?
It might skip one object.
Yes.
Yeah, exactly.
Yeah, this might skip objects. The thing is, I'm deselecting, so I'm removing objects from the selected object list. And depending on how that is implemented exactly in Blender, it's going to work or not, or crash, or burn, or... So my general approach here would be to construct a second list and to have two loops. So the first loop finds the objects that we want to operate on. That I just put in that other list. And then in a second loop, I can safely loop over that other list that is now no longer related to selection or whatnot. And I can do the thing. This is another really nice, subtle one. It looks very similar to what we did before, except that this loops over all the objects in Blender's memory instead of all the objects in the scene. And the objects in Blender's memory are sorted by name so that they can be quickly found. And so changing the name will reorder the objects. And so you will visit some objects double and you will skip over some other objects. This is another way to fix things. So that little alien looking is slice notation. You can say, I want to have from number 3 up to, but not including number 6. And if you remove that last one, you get from number 3 to the end of the list. If you remove the first one, you get from the beginning of the list up to, but not including number 6. If you remove them both, you just get a copy of the entire list. So this first creates a copy of the list of all objects, which fortunately is not a copy of all objects, is a copy of the list of all objects. And then you can, again, have an independent list that you can work with. Another common pitfall is using bpy.context when you get a parameter that's context. Often enough it's safe, often enough it's fine, which is the tricky thing because it works. But especially for things like the application handlers, where, for example, you have a on frame change post handler. That gets a context parameter. That frame change could be because you're working in the 3D viewport and you're scrubbing the timeline, but it could also be because Blender is rendering and it's going from frame to frame while rendering, and those are both calling the same function except with different contexts, and both can happen at the same time in different threads. And so you want to, if you get a context from Blender, somehow use it. If not, you default to the global one. Another issue that I saw, and that has been for a while been spreading quite, is assuming that the things in bpy data.something, the names are unique. This is not the case. Blender only enforces that the names of, let's say, objects within that one blend file are unique. So you can only have one object named cube in that blend file. But from that other blend file, you can just link in the cube. And from all the 5 other blend files you have, you can also link in the cubes. And all of a sudden, you have 6 objects, all called cube. I've seen an approach where people were using those names to identify objects, and every time they wanted to do something, they were looking it up in bpy.data.objects. We know the Steve approach, and just give it a name and use that, and it's way faster and more efficient, and it just keeps working. There's a whole bunch of other gotchas and things and lovely ways how to crash Blender. That's all documented here, so I'm not going to go over more of those. Now we get to editing code. So talk about the pros and cons of the text editor, but now you actually see the slides. We left off with the thing being confusing on disk. So when you open a file from disk, it creates a text data block in the blend file. When you save it, it saves the blend file with that text data block in it. So Control-S saves the blend file as usual. Alt-S saves the current text that you see to whatever path you loaded it in from disk. So the thing in the blend file and the thing on disk can get out of sync. It always confuses me, so I try to avoid this. Also, it has no debugging support, it has no Git integration, it has no code folding, it has no like Control-Shift-F finding across my entire project, which I use all the time. And so there are many reasons why I don't typically use the text editor for coding. Which brings us to Visual Studio Code. Open source code editor, I quite like it because I can mix all kind of different languages in there and it keeps working somehow. So that's where we're going to use, you've seen the slide, I hope everybody is set up. And we're going to finally create our add-on extension, add-on plugin extension. Used to be add-ons, are still add-ons, but also extensions. Since 4.2, I think, yeah, we have the extensions platform. We have theme extensions and add-on extensions, and so what we're going to make is an add-on extension. Blender doesn't have plugins, because that's like the C++ kind of thing that we all want to have, but we don't. So let's make one. In VS Code, open a folder. Also on the slide was somewhere, create a folder somewhere. So create a folder somewhere, like on your desktop or something. Call it demo add-on or something without spaces, just a simple word. Open folder, that folder in VS Code, and then Ctrl-Shift-P to get to the command palette, and type Blender new or something like, or Blender N, enough for the autocomplete to do the rest. That will give you a little pop-up, and that's going to ask one question at a time. First name is, do you want it with autoload or not? You do, at least for now. You press enter, enter the add-on name, do something like conference demo. Again, keep it simple. Fancy names we can always put in later, but for now this also translates to some Python code, and so it's better to keep it ASCII only, no spaces, very simple. Then your name, I'm a code monkey, and this sounds like this. Say no to legacy Blender support. It's not drugs, legacy Blender support. This is just like, do you want to support pre-4.2 versions of Blender from before we had the add-on, the extensions platform? It just is, for now it's double bookkeeping, we're not going to do it. Then start Blender from Visual Studio Code. If you have Blender open, close it. In Visual Studio Code, Ctrl-Shift-P, Blender start. Then you get to choose a Blender executable. I think the default one on your system should just be in there. You can click on it. And that starts Blender for you. But also that does some secret sauce of that Blender development extension for VS Code that we're going to use. So keep the Blender open to keep that connection going. If you haven't done it yet, in the interface preferences, enable developer extras and Python info. And when you go to the add-ons, you will find your own add-on there. I think it should be enabled by default. If it's not, give it a check. But it should be there. So this did a bunch of things. It created the add-on files. It added a local extension repository to Blender. It created a symbolic link for wherever you decided to have your files to where Blender wants those files to be. So you can work in the place where you want, and Blender finds the thing where it wants, and we're all happy. It installed some support packages that it needs for all the fancy stuff. And that's it. And that config, that depends on like where your operating system. I think this is fairly known to most Blender users. If not, it's not that interesting for now. It also created a Blender manifest.toml, and this is the file that since 4.2 indicates that this is an extension. And you can see there, type is add-on, that could also be theme. If you now want to make a more fancy name instead of just conference demo, you change the name there. Not that important for now. If you want to package this for distribution, I'm briefly going to show you, we don't have to do it now because we're not distributing anything. It's a bit fiddly because you need the Blender from the command line. And again, I always forget how it's working. So we're going through my steps. First, you can just zip it. Just zip the files, you're done. You made mistakes in the manifest file, nobody tells you. But it works. You can also do the command line thing, and then Blender does a few checks for you to make sure that stuff is consistent. These are various paths where you can find Blender, depending on your platform. I always forget the exact command, but I know it's like the new command thing, so that's -C. That's how far I remember, and then I do help because I don't know, and then it tells me I have one. It's called extension. Okay, let's go there. Okay, Blender-C extension. More help. One of them is build package. That's what we want to do. So from within the directory of your add-on, there's, by the way, a terminal in VS Code that will give you some command prompt in that directory, so that's easy. You do Blender-C extension build, and it will tell you that it's building, the name with the version in there, and it also did some checks, so it starts screaming at you if you did something wrong. And then finally, you have that zip. That zip you can upload to the extensions platform, or you can upload to your friend, well, send to your friends. They can just drag it into the viewport of Blender. If you put it on your website, link it, they don't even have to download it, just drag that URL from the website into the viewport, and Blender will give a pop-up so you can install it. So now, let's add stuff. We have our operator, we can ship it to people, it doesn't do anything yet. These operators are the things that do things, and they have a few flavors. So the simplest one is execute. Also, I have to keep track of the time. Simplest one is just we built an execute function, and whenever somebody clicks on the button or the menu item, that's what runs, done. You can also have a pop-up UI. Then you want to invoke. The invoke function is called whenever your operator is called from a user interface element. So when it's called from Python, it just does the execute. When it's from the user interface, you get the invoke. So there you can distinguish already between I'm going to show a user interface or I'm just going to do the thing. Usually that user interface is, hey, Blender, draw my properties. That's how like the bake action works. And then you can also have a modal operator. That's a thing that runs for longer and can respond to like mouse clicks in the 3D viewport and button presses and all those kind of things to have a more complex tool. So let's make one. Again, we're going to use the easy thing with the add-on, the Blender development extension. If you create a new file, operators.py, can just be an empty file. While your cursor is in that file, Ctrl-Shift-P, Blender new operator, ask for a name, we call it monkey grid, and then you get pretty much this code. The only thing I added is self-report, curly braces, info. You are amazing. For C++ and other that kind of language developers, the curly braces with a string, that is Blender's way to expose enum flags to Python. So this is just, I want to have an enum type report, but written in a bit of a weird way to be Blender compatible. Also this line, you will see in your editor, this is going to give you red squigglies, it's going to error out. Because it's not run, like VS Code doesn't know that you're going to run inside of Blender. So it tries to load that as a regular Python module, it's going to fail and it's going to scream at you. In the end, I hope we have the time, but we'll look at a few ways to try and resolve this somewhat. The execute is what's going to run. So try it out. Copy paste it into the file or create your own. Save the file. Switch to Blender, which I hope you haven't closed yet. Then press F3 to search for Monkey Grid. If you cannot find it now, go back to your user preferences and enable the developer extras. Because otherwise, F3 will only find the operators that have a menu item. If you say I'm a developer, you find everything. And you find your monkey grid, you press enter or you click it, and then it will tell you in the status bar that you are amazing.
Okay, so where to enable it?
Sorry?
Where to enable developer extra?
Yeah. Thanks. So adding functionality, you can add stuff directly to that execute method, but often it's a bit awkward to call Python, to call operators from Python code. So the operators are really meant for hooking up to menu items and hotkeys and that kind of thing. So if you want to have some functionality that can be an operator but could also be used by other Python code, it's better to put your core functionality in a separate function by itself and then call that from the operator. Also, we're going to add the ability to undo to the generated code because this is kind of nice. So first we get a monkey grid. I made it slightly smaller. Instead of 600, we go for 25. But it's the code that we saw before, except that it's wrapped inside of a function that starts with def. It tells Python, I'm not returning anything. And then to hook up the operator, again, we have like the stuff we already saw. The thing we add is monkey grid we call. And I wanted to have a description that will be the tooltip for a button or a menu. And the BL options is a list of options for this operator. Register is the default one. There's also internal, which is the opposite of register. Internal is for things that Blender uses internally but should never really be exposed to people. This should be exposed to people, so we use register. Undo is the thing that we add. This tells Blender this operator is changing data, and so an undo step should be put in place. If you miss this out, what you will get is that you undo, and then it undoes the operator and the thing before that. Also, this return finished tells Blender the operator did its thing. You can also say return cancelled, in which case you tell Blender it did not do anything, and it won't create an undo step. So we can try it on the console as well, bpy.ops, and then we had that BL ID name there, object.monkeygrid. So just prefix that with bpy.ops, and there you have how to call your operator. Now let's add it to a menu, because we want people to find it. And this is going to be a two-stage process, because Blender brings us halfway, and then we have to guess it a little bit. So the top-level menus you can hover over, and you can see in the tooltip which menu it is. So that's View 3D MT Add. The MT stands for menu type. And Blender stuff is typically called category in capitals, underscore the type is a two-letter code, underscore the rest of the name. We have operator type, panel type, menu type, header type. I think that's it. And so we're going to look for View 3D MT something. First, let's just add it to the top level add menu. It's not where we want, but it's what we get from Blender. So if you create a new file, GUI.py, and then put this code in, you can see that you can append and remove from these menu types. And menus and operators, you can just treat them as if it's sort of a list and just append things to it if you want to append things to that menu. The thing you append is a function that will draw the things you want to draw. And that is this draw menu function that gets self, which is the menu that you were appending to, and again the context. Layout is like self.layout is like the typical way in Blender to get UI layout stuff. And then that has an operator function that you can just give that BL ID name again to add that particular operator to the menu. And this is how any add-on can expand on any menu and any panel in Blender. As you can see, I also don't need the code for the operator. I don't need to have that class that we made earlier. I just need to know that string. So even if you want to build a menu of stuff that you did not write, if you know that BL ID name of the thing you want to put in that menu, you can do it and construct your own convenience menus that way. So add all the way at the bottom it is. It works, but I want it in mesh because we're adding monkey meshes. So I'm just going to guess it's view 3D MT something, probably something with mesh. Type on the console, tab completion is your friend. I found the one with mesh add. And so instead of adding it to the add, I added to the mesh add, and then it works. And I add a little icon for a monkey as well that's built in. I have hand.
Sorry, I have a question. Maybe I missed it earlier. What was the error annotation?
Oh, that is Python type annotations. I love it. I'm not entirely consistent for brevity of the presentation, but for parameters and return types, you can just say, I'm expecting this type here. And that means that your IDE, like Visual Studio Code, knows what you were expecting and so can do more auto-completion, that kind of stuff.
But it's not enforced in C Python.
It's not enforced, no. It's just, I'm declaring that I want something like this. If you put it, but it stays Python. So if it smells like a duck and it quacks like a duck, it's probably a duck. Even though you expect a duck, you can throw in a goose and nobody will complain. More questions?
One more. From the top of your head, do you know if there's any easy way to reorder menu items?
No.
Because the way you have shown, okay. The way you have just shown, just add the
Yep.
menu to the end of the list.
Yep,
And yeah, okay.
I think that's it.
Repeat the question.
Oh, sorry. The question was, can we reorder the menu? No. I heard that there's a possibility to put it at the start. That's it. Anyway, now it's in the right menu with a nice icon, and we're all happy. Moving on, because we've got a lot of stuff to cover. You can parameterize your operators. That works with bpy.props.someProperty. And there you can say, well, this is the count X or the count Y, and is a default value. It has a minimum. You can set the minimum and maximum. That's the hard limits. You can set the soft min and soft max. That's what you get with the slider, how far you can go. And once your execute function runs, you can access those properties by self dot the property, and that will give you the value. Again, your VS Code is going to scream at this, because this approach was a bit older than those type annotations we just talked about. So Blender's use of the same system in Python is slightly different than what is normal use now, and so your IDE expects normal use and is going to scream at you. Monkey grid needs a slight modification. Here I also added the count X, count Y, and declared these are int type. And from the Python console, again, you can see them with tab completion. You see the parameters are there. It just works. If you do it from the menu, you also get the redo panel. And you can also show them, as I said, in a pop-up. This is just literally taken from one of those Python examples. I'm quickly going over these guys. go for more interesting stuff. The Visual Studio Code extension also supports debugging your Python code, and I think this is super, super cool. Initially, I didn't even really have it in the presentation because it's boring, because it just works. But for those who haven't worked with VS Code and debugging, quick demo. So if in your monkey grid you set a breakpoint, and that means clicking at that red dot so that the red dot appears. That sets a breakpoint. As soon as Blender hits that particular line in the code, before it actually executes that line in the code, it will pause. So if you think, what is wrong with my code? Why is it hanging Blender? Why does Blender not respond and seems to crash? No, that's just because it's waiting there, and this breakpoint stops the entire planet. So just go back to VS Code and see that it's waiting for you there. This is what it will look like then. It will highlight the line where it's on. And on the left, you will see the variables. So this is the first time this line is run. So the index is 0, the x-coordinate is 0, the y-coordinate is 0. And you can see that the execution started from the execute function, and then it called the monkey grid function. And you can also see how Blender got to executing that code. So that, for me, it's super important because Blender is such a big program and it can be so complex, and it can be all kinds of different ways in which that code gets run. So sometimes I just set a breakpoint to figure out how it got there. And with VS Code, I also use it for Blender C++ code. Works exactly the same way. So there in the top right, you see some buttons. I'll quickly go over them, what they mean. This is not a button, that's just a grabby thingy so you can move them to a useful place. Pause will just pause Blender, like as if it's on a breakpoint, but just on whatever it's doing at the moment. I haven't used it while debugging Python, so I don't know if it works, how it works. Then I feel that these three are a little bit weirdly directed, because this goes to the next line. So if it's it is on a function right now, it will just call the function and then break again when it's on the next line after calling that function. So the thing that it jumps over the function call basically, and the next one goes into the function. So that goes to the first line inside of that function. I feel the arrows are a bit confusing because the one that goes to the next line below my function call is the one that is drawn as skipping over it. So anyway, this restarts the whole process. It's a default button from VS Code. I don't know how well it works when you do it for the Python thing with a special way to start Blender again. And this disconnects. So this will just make VS Code back off from your running Blender, and then you can't debug it anymore. Now let's look at custom properties. I think every Blender user has run into custom properties at some point that you can like add that there to your object, and you also see it in the side panel, and you can say, well, this object has a barcode, or this bone has IK enabled, and that kind of stuff. Those are custom properties, but that's not the only way to add custom properties to your object when you're a Python developer. And that's called the RNA properties. I'm not going into the name RNA. It's sort of the Blender's Python wrappers for things. And the cool thing is, like the bpy.types things, we've seen it before. So Blender objects have the type bpy.types of the object. If I want every object to have be able to like inventorize things, I want to know what's the weight of the thing and is it in my inventory or not. Then I can say I add a property here, my inventory include, which is a Boolean property. It's the same kind of properties that we've seen before with the parameterization of the operators. And in this case, like the include is no, I don't want to include it by default. It has a name for the user interface. And also weight, it's a float property because it can be any floating point number. Default is 1, I set some minimum and maximum. And the cool thing is you can set units as well. So this is mass. And then depending on whatever people configured in their scene, units if they want to have it like in normal units or freedom units. You get that. So that's in your register function. In the unregister function, you can just delete them with the del keyword. Also, my apologies for the weirdnesses that you sometimes see here. It's an incompatibility of how I use it with that handy copy-paste button. I didn't want to remove the copy-paste button.
Is the register function called on reload?
Sorry?
Is the register function called on reload?
Is the register function called on reload? Yeah, and we'll look at reloading later. For now, it's the with autoload thing that we said yes to. That also finds all the classes that we made, that finds all these register functions and called them at the right spot. It's a bit of magic, but it makes it easier to move along. Finally, in your code, you can just say, I get some object that's just a default Blender object, and you can just use object.myInventoryWeight. So now we've seen two ways to add custom properties. There's one from the user interface that gives you the with the quotes and the name. And then there's this guy. So how do you choose? Well, those custom properties are mostly for humans. Like people using Blender want to add some custom stuff there. They should be able to. They can. The RNA properties are aiming at code. Python dictionary notation, and this is something I want to briefly mention. That's the square brackets with a string in there. For custom properties, it's the only approach. Before Blender 5.0, also for the RNA properties, this was possible to use because they were all heaped onto one big pile of custom properties. Blender 5.0 splits them out cleanly. So you either have the .myInventoryWeight or you have the barcode. The last one I think is the most important one. So the custom properties that you add through the custom properties panel are only added to that specific object. And so if you add a property prop there that's a float, another object may not have it, a third object may have the property prop, but it could be a Boolean. There's no consistency between all those objects. Whereas if you do it through an RNA property, you really tell Blender, like, hey, this property has this type, and it will always be that type. So that gives you more certainty as a developer. So I would always go for that one. So I've already mentioned a little bit, like this is the tooltip, this is the name for the user interface, so let's build one. Of course, we get inspiration first from Blender to see how it's done. So I would say in the 3D viewport, press Shift F11 to turn it into a text editor. And then in the object properties, right-click on location X again. Instead of copy full data path, choose the edit source. And that will open the Python file that constructs that part of the user interface in the text editor that you have open, and scroll to the line that actually draws that property that you right-clicked. And that looks something like this. So we have some layouting going on with rows and columns, and then it draws the property of some object, and that property is called location. And because that location property was declared as I am a three-dimensional vector of type distance, Blender knows that it should draw the X and the Y and the Z in that draw function. This is a bit of a weird thing. So in Python, classes can have multiple superclasses that all get sort of merged into this thing. So this is just a way to make things consistent. If you have a dozen object buttons panels, as Blender does, you can put the common thing in a superclass. This is exactly the same thing. Like, effectively, all those properties are available on that panel, and so this is how you really should be looking at it. If you're creating one panel by yourself, this is how you would do it. So the panel itself declares where it should be shown in the Blender user interface. You have no .append is necessary to add a panel somewhere. Again, I always forget this stuff, so I always view source of a thing where I want to add it. But this says, I'm in the properties editor, region type is window, it's just in the thing. BL context is object, which means that it's in the Object Properties tab, and then the label is what is shown at the top of the panel. Sometimes you will see this. Usually for the more interesting layout. So let's do this ourselves. To be fair, I started this as part of the object properties, and then I started building the panel and started adding an operator and putting some properties in there that I liked. I click on the monkey grid button, I get my monkey grid, and I get no redo panel. I get no parameterization, I get no way to edit what I just did. And then I realized, oh yeah, the redo panel is shown in the window in the editor where you clicked on the thing. And the properties editor has no redo panel, and so you don't see it. So that's why this example moved from the properties editor to the 3D view. Space type is view 3D, because there we do have a redo panel. Region type is UI, because I saw that in other things. Category is cat.
Where is this source then?
This is in GUI.py. And because of the magic of the autoload.py that's also in your sources, you don't have to do anything else. You just write this class, and that thing will find it and deal with it for you. So it doesn't really matter. As long as it's in a Python file in your sources, it will be fine. And then we get the draw function, again with the layout. Use property split is what things do, so that looks nice, Python, Blendery. The layout.operator allows you to put operators on there. And you can also do things specific to the current object. So in this case, I wanted to have the name, the parent, and whether it's shown or not in the 3D viewport. Normally these are in wildly different places in Blender, but it can be very useful if you, for your workflow, just put the things that you find important in a little panel somewhere where you can access it. Brief thing about aligned layout or not. So if you create a column of stuff, you can say align is false, which is the default, and then every property is sitting there by itself, nicely rounded corners, little space between it. If you say align is true, it is just squished together. And it's only the top one that has the rounded corners at the top, the bottom one has the rounded corners at the bottom, and it's all just drawn as a more one group of things. You can also do conditional layout. Because this code runs every time that part of the UI is drawn, you can just say, well, I only want to show the viewport color property if the object is shown in the viewport. And then you can just write it like that. It's super simple. Also, your custom properties are just there. For what you often see is that the property itself gets like a nice descriptive text. So you know what it's about when you look at it outside of context. But here we're going to draw it in our panel. In that part, that's about the inventory. So I don't have to say my object inventory weight because that label gets way too long. So you can just say text equals, and that is the label that we'll put in front of the property. And then you get this. And then you can change things around and play with it. In the zip version of the final shape of the add-on, I added a little bit of extra code that goes over all selected objects, and the ones that are in our inventory sums up all the weights, and just in this panel also shows the total weight of all the objects in your inventory, just to have a little demo of how you could draw that stuff. It's going pretty well. Then, let's get rid of the autoload, because that is the thing that we got for free that we've been using so far. Is wonderful, but it does require that special startup of Blender that we did. And your code should be reloadable. Like when you publish an update, then people pull in that update, that should be able to just properly reload everything. And also while developing, it's kind of nice if you can just, in Blender, say reload, and then it reloads. So this is what we had. The init___.py. In Python language, that's called dunder for double underscore, dunder init. That is basically the add-on as Blender sees it. The rest is up to you. So when Blender is reloading it, it's going to reload this thing. The register and unregister functions have to be there in that dunder init file. If it's not, Blender will start complaining that your add-on is broken. So when you enable the add-on, the register calls. If you disable the add-on, the unregister calls, but also on reload, register, reloading, unregister, reloads, re-register, that kind of thing. So now we have to do it ourselves. So far we've constructed an operators.py and a GUI.py. So we import those from the current package, and in the register we just call the register function in there. Maybe they don't have it yet, but we'll make sure that they're there. So for operators.py, you can write your own register and unregister, but you can also construct a list of all the classes that you want to register with Blender. And in this case, we have one, that's our monkey grid operator. So I just say underscore classes. The underscore indicates like, hey, this is private to this file. It's uninteresting for anybody outside. That comma is important. If you do 3 plus 5 with parentheses around it times 2, it will do the 3 plus 5 first and then do it times 2. That's the kind of parentheses you get without a comma in there. If you have a comma in there, it's constructing a tuple of multiple things. If the multiple equals 1, you still need the comma. And then that thing you can give to bpy utils register classes factory. You give it your classes, and it will spit out the register and unregister function for you. And again, Python is Python. Names refer to objects in memory, and objects are like the general, it's a Python thing object, not Blender objects. These are functions. Functions are also objects. Everything is objects in Blender. So these are actually functions that do the registering and the unregistering, and we've named them register and unregister, and then it just works. You can call them like we did in the other file. For the GUI, same thing, except that we already have a register and an unregister function, but also we have the panel, and the panel we have to register with Blender as well. So we can't use literally the same thing as we did here, because then we have 2 register and 2 unregister functions, and just last one wins. Just like we had with the Steve equals 3, last one wins. So what we do, I typically do, I just say, okay, I'm going to do exactly the same trick, I'm just going to name them differently. And then in my register, I call the underscore register. In the unregister, I call the underscore unregister, and then it's done. So this gets rid of the auto load magic, finding what we made, and then registering everything. Then we get to the reloading, which is slightly different. So, little trivia. Import some module when you write that in your Python code. That loads some module of Py from disk. True or false? Who says it's true? You can, yeah. As we say in Dutch, you can see the rain coming. You're right, it's false. What it actually does is, if you have that import statement, if it already loaded in that file, it's already in memory, and it's just going to refer to it again and again and again, because it's a shame for every import load it from disk again. If you go to the Blender icon system reload scripts, it will reload your scripts, and that will unregister the enabled add-ons. It will call a function, Python standard library function, to reload that module, which is that dunder init.py file. And then it registers the add-on again. So it only reloads from disk your dunder init.py and not everything you imported from there. So we have this code, and it's going to rerun this and reload and everything, but the old GUI and the old operators are still in memory. So you have to reload your submodules yourself. This is something that messes up IDEs wonderfully. So the way Python reloading works is that if you have code like this, you have the name operators and the name GUI. These are, again, are Steves that refer to these modules in memory. When it reloads this, it will try its best to keep their value around. And so that means that until you explicitly assign something to it, it will have the value from before the reloading. Locals is a function that is a standard Python function that returns which local variables there are, which local names there are. And so if the name GUI is floating around in there, we know that we're reloading because it has some value, it exists. And we can use that as a trigger to say, okay, I'm going to reload the operators in the GUI. And we can use those names because they still have the old value. Yes?
So for the register for RNA, where are those contents stored?
The registers for RNA, where they're put, you're right, the reloading part is newer than the RNA properties part, but you would also put that in those register functions.
Okay, is registered because both operators and GUI work?
Yeah.
Okay.
And another question over there.
Yeah, just a comment. You can also move the lines before clear and literally repeat it after line 8 and drop the if to me. That also works.
Yes, I'm getting there. What he said was right, you can reshuffle those lines because IDEs do not understand this life cycle of this code has been run before and it's now going to be reloaded, and I'm ensuring that this kind of works. In a
Would both those methods cause the module to be imported twice?
Would this cause the module to be imported twice? No, because this imports sees that, in technical terms, sys.modules already contains the name, and so it will just, yeah. But like you can see that this has no copy button because I don't want you to do this. This does have a copy button. So I just say needs reload equals GUI and locals. So need reloads is going to be true or false depending on whether we need reloading or not. Then you can say, okay, just import whatever you have, and then if it needs to be reloaded, we reload it. And IDEs, like development environments, they do understand this because you have the import first, and then you use the name, and then it's happy. So even though both codes work, this will make your IDE auto-completion and that kind of stuff so much happier. Finally, faking the bpy to get rid of some of the squigglies. This is a bit trickier, so I'm just like, you can follow along, you don't have to. We need to build a virtual environment, which is a way for Python to be able to install stuff that doesn't get installed into your system. Python is just for this project. It makes things more local, more manageable. You create one through Visual Studio Code, and then there is two possible packages that you can install. The top one is one that I found myself. The second one is somebody who approached me at SIGGRAPH, like, hey, I built something like that too, but it's better. He builds it by extracting information from the Python documentation, actually. He parses the docs and uses that to generate all the stuff that the Visual Studio Code needs to understand how it works. The thing is, Blender is quite complex, and that bpy.context is really dependent on the context. If your panel is being drawn in the modifiers panel, there will be a different context than when it's drawn in a panel in the action editor. And so you really need to run Blender and know what's going on in order to properly give people auto-completion in their IDE. Well, that's just not useful because you may want to write code for a situation you're not in at the moment. And so that's why there are these fake approaches that generate fake Python code that doesn't do anything, but it looks like Blender and it auto-completes like Blender. Sometimes it's not entirely correct, or it needs to take into account all those possibilities, even though you're only in one specific case with your code, it doesn't know that. And so you may need to get rid of more squigglies, you may need to write some assertions. Like, you know that there will always be an active object in that part of your code, but the fake Blender doesn't know that. And so you need to write like assert my object is not none, and then it understands, okay, yeah, okay. We're good. Lots of stuff we covered, lots of stuff we didn't cover. Many Blender areas are there, like preferences for your add-ons and how to like mesh editing and dynamic generation of animation data, and you can go as far as you want, but I think we've got a pretty decent covering like this. Multi-threading has issues, I'm sorry. Multi-processing works quite well, except that we had to lean into that, and then the iPad said, no, you're not running. So stuff like that we're not covering, but this was pretty much a race, wow, with like 10 minutes left. Thank you very much. As I said, we have 10 minutes left. Any questions?
The virtual environment, is that something that Blender actually activates when your add-on is loaded? Or?
Is the virtual environment something that gets activated by Blender? No. So that's perfect for installing like that fake Blender, because your IDE does load it in and it doesn't get in the way of Blender itself.
And if you need other external packages, like Blender will load them when loading your add-on?
No, if you need, like, so if your add-on needs external dependencies, they need to be handled like specifically, and it's always a bit tricky. But this guy knows much more about it. There's documentation about it on the extensions website. More questions? Yes?
I was wondering about the properties in the operator class. Is the superclass basically a data class, or why can't we use colon notation for the properties?
The question was about the operators. Why can't we use the colon notation? So we're talking about these guys.
Yeah.
Historical reasons. So this used to be notated as count x equals b pi props int property. And the problem then is that your IDE would complain because the self.countx, it would expect it to be a property because that is what you assigned. But it is actually an integer. And so that it got confusing, so that's why it was replaced with the colon notation instead of an equals. Nowadays,
It should be the same thing.
I think the best way would be to say count x equals the property colon int, to declare to Python this is actually an int value that is managed by some other thing. But yeah. More questions? Yes.
Do you recommend stealing your auto reload and like loading method? Is it like safe enough for a big add-on?
Do I recommend the auto loading thing? Well, it's not mine, so therefore I can't really recommend it. Also, I think it's superb for development. It also tries to figure out what to load before what if there's like interdependencies, but that means it's doing quite a bit of heavy lifting. And so for a bigger add-on, I would want to have control over that. I want to have control of the order in which things happen, and so I wouldn't use it.
With the add to that question, I made a plugin with 2 or 3 modules, and the auto-loading draft looker became very hard to control, very quickly. So I will probably switch it to manual registering because it also can handle handlers, and it makes a mess, and it's very hard.
To summarize, man with experience. If it gets big, write it yourself. Yes?
Can we make it into like
create a custom modifier or a node?
Can you create a custom modifier or a custom node? No. No. But, yeah. So the real answer is yes, you can create custom node types, but the evaluation of that will always be in, like if it's geometry nodes, for example, it will always be a geometry node. But you can create custom nodes from Python and then use them yourself. For example, the Mantis rigging node add-on does that, and it just investigates for itself what you plugged into what, and then generates a rig for you based on that. So in that way, yes, but modifiers, no. Let's do two. Yes.
About multi-threading and multi-processing, what would be the best way to have like Python running heavy stuff?
Okay, multi-processing, multi-threading, what's the best way to go about it? Currently and it's a long-standing issue, there is some issues with multi-threading. I was also quite surprised by it. I only learned about that fairly recently while just finishing up on a multi-threaded thing. And then Campbell was like, yeah, it might work for you, but better not. So that was for the remote asset library project. So now what we do is we spin up a background Python process. Blender comes with a Python executable as well, so you can just run it. You don't have to spin up an entire Blender to do background stuff. And then you can run it like that and just monitor what it's doing.
So it's not basically would not freeze Blender while it's working in background, right?
No, that just runs in parallel. Last question.
Super specific. The custom Python nodes, I made a couple of types as well, but I cannot change the header color because they're all red. Is there any way that is exposed for?
So the question is, can you change the header color for custom Python nodes because they're all red? Nika says yes.
They were just documentation. You just didn't look.
I looked very hard.
Thank you all again.